Okay, picking up where we left off, we're now going to solve some triangles. When we solve a triangle, we might have to use results from a previous calculation to calculate something afterward. I want to show you how to store some of these results on your calculator to preserve accuracy. So on your calculator, once you've made a calculation, let's say that the answer was 3. I'm going to press 3. If we want to store 3 in a variable on the calculator, you're going to press store, which is accessed by the control key, which is the blue key, and the variable key. You'll notice that above it, it says store, followed by the letter where you want to store that result. So I'm going to store 3 in C, press enter. Now, every time that I type the letter C after that and press enter, 3 will result. If I type 5 times C, 5 times 3 will result. This is going to be very handy as we do other calculations. So, in the next example, we're going to be solving a triangle in which we have 2 angle measures given. So we have 64 and 38 degrees in triangle ABC, and we also have side B is 9 given. If we think about the pattern of givens here, the pattern of givens is 2 angles and a side, where the side is not in the middle, so this is angle, angle, side. And then, if that's the type of pattern of givens, we should use the law of sines. The law of sines will always be simpler to use, so we're going to use it if possible. So sine of 64 degrees over its opposite side, which is 9, is equal to sine of 38 degrees over its opposite side, which we would call C. Now we can cross multiply to find C. C times sine of 64 degrees is equal to 9 times sine of 38 degrees. Dividing by sine of 64, we have 9 times the sine of 38 degrees over sine of 64 degrees is our exact form answer for C. Now we're going to utilize the calculator to find its decimal equivalent rounded to the nearest thousandth. I would encourage you to use a template for the fractions. Control and divide gives you the horizontal fraction bar. Then in the numerator, we want to type 9 times the sine of 38 degrees. And then downstairs, we want to type sine of 64 degrees. Press enter. We get 6.165 approximately. Do realize that that is an approximate answer. It has been rounded off. I'm going to write in our approximate answers here as we get them on the diagram. Now, there's actually one thing that's very easy to find that we haven't found yet, and that's the third angle. The third angle is very easy to find because all we have to do there is subtract from 180 degrees. So measure of angle A is 180 degrees less the 64 degrees and the 38 degrees. So measure of angle A is 78 degrees. That's important because we're about to use that information. Since we now have angle A, we can now find the side length that's opposite it using law of sines. So sine of 64 degrees over 9 equals sine of 78 degrees over A, which is the last remaining side. Cross multiplying A times the sine of 64 degrees is equal to 9 times the sine of 78 degrees. And then dividing, C is 9 times the sine of 78 degrees over sine of 64 degrees. And now we can get an approximate answer. I'm just going to use the cursor up and press enter to get that same calculation that we just did and change the 38 to 78. If you don't feel like retyping, that's a good way to save some steps. Then we get 9.795. So 9.795 is the value of A. I know that looks like an A. That looks like a C, excuse me. That was supposed to be an A. A is 9.795 approximately. So now we have all of our approximate angles, an exact angle measure, and two more approximate side measures. Example 2b is a lot like that one. If you want right now, stop the video and try this one on your own. I'm going to write in the answers, so go ahead and pause. And when you're ready to restart the video, the answers will be there. Measure of angle F is equal to 77 degrees. That's easy to find by subtracting from 180. Side D, using the law of sines, after cross multiplying, that should turn out to 44.638. And then side E, after using the law of sines once more, should turn out to be 58.346. In example C, we have a little bit of a different setup. Let's make a sketch first. Triangle XYZ. Doesn't matter if the triangle is drawn to scale or not. Angle Y measures 127 degrees. Side X measures 15.8, and side Z measures 2.6. Now, what you'll notice about this pattern of givens is that we have two sides and an angle, and the angle is in the middle of the two sides, so we have a side angle side sort of a situation. That means that we're going to use the law of cosines. Since we have angle y, we want to start our law of cosines with y squared equals. So y squared, which is the side that we don't have, is equal to x squared plus z squared minus 2xz cosine of angle y. Now we're going to make some substitutions. Y squared is equal to 15.8 squared plus 2.6 squared minus 2 times 15.8 times 2.6 times the cosine of 127 degrees. I'm going to let the calculator do as much work as possible. In order to solve for y, all we need to do is to take a square root. So y is equal to the square root of 15.8 squared plus 2.6 squared minus 2 times 15.8 times 2.6 times the cosine of 127 degrees. We can actually put that entire calculation into the calculator. So the square root of 15.8 squared plus 2.6 squared minus 2 times 15.8 times 2.6 times the cosine of 127 degrees. Enter, and the calculator gives us that 3-digit approximation, 17.488. So now we have the third side, and we just need two more angles. In order to find the angles, we're going to use the law of sines. So sine of 127 degrees over y is equal to sine of angle x over 15.8. Now we know the value of y, and we can actually store that value. And then use it to find angle x. If we take this equation and we cross multiply, we're going to get sine of angle x is equal to 15.8 sine of 127 divided by y. If I want to solve for the angle, I need to take the inverse. So the measure of angle x is equal to the sine inverse of 15.8 sine of 127 degrees over y. What I'm going to do is to use my stored value and type that whole thing into the calculator. So I need to store that value that I just had by pushing Control and Variable, and I'm going to tell it to store it in the letter Y for easy reference. Enter. Now you notice that the calculator is actually storing much more than just the first 3 digits after the decimal point. The next thing that I'm going to do is type what we had, which was sine inverse of 15.8 sine 127 over y. So sine inverse of Control divide to get a fraction, 15.8 times the sine of 127 over y. And now I just type a y in there, press enter, and it gives me an angle measure for x of 46.181 degrees. Now that we have two angles, we can find the third angle by just subtracting from 180. So measure of angle Z is approximately equal to 180 degrees minus 127 minus 46.181. And so that's going to give us measure of angle Z is approximately equal to, let's consult the calculator, 180 degrees minus 127 minus that 46.181, and that's going to give us 6.819 degrees. And that's it for the video.